Welcome to doassignment-ca. Here is the problem. A 20-kilogram crate is subjected to a force having a constant direction and a magnitude F equal to 100 newtons, applied at 30 degrees above the horizontal. When S equals 15 meters, the crate is moving to the right with a speed of 8 meters per second. Determine its speed when S equals 25 meters. The coefficient of kinetic friction between the crate and the ground is mu sub k equal to 0.25. Now let's work through the solution step by step. We use the principle of work and energy, which states that the initial kinetic energy plus the net work done equals the final kinetic energy. The crate travels from S equals 15 meters to S equals 25 meters, a displacement of 10 meters. The mass is 20 kilograms, the applied force is 100 newtons at 30 degrees above horizontal. The initial speed is 8 meters per second. The coefficient of kinetic friction is 0.25, and g is 9.81 meters per second squared. Since the crate does not accelerate vertically, the vertical forces are in equilibrium. The normal force equals the weight minus the upward component of the applied force. That gives 20 times 9.81 minus 100 times sine 30 degrees, which is 196.2 minus 50, equaling 146.2 newtons. The upward component of the applied force reduces the normal force. The kinetic friction force equals the coefficient of kinetic friction multiplied by the normal force. That is 0.25 times 146.2, which equals 36.55 newtons, acting opposite to the direction of motion. Now we calculate the work done by each force over the 10-meter displacement. The applied force does positive work through its horizontal component. 100 times cosine 30 degrees times 10 equals 866 joules. Friction does negative work. Negative 36.55 times 10 equals negative 365.5 joules. Weight and the normal force are perpendicular to the horizontal displacement, so they do zero work. The total net work done on the crate is 866 minus 365.5, which equals 500.5 joules. Applying the work-energy theorem, the initial kinetic energy is 1/2 times 20 times 8 squared, which is 640 joules. Adding the net work of 500.5 joules gives a 140.5 joules. Setting this equal to 1/2 times 20 times v sub 2 squared and solving gives v sub 2 squared equal to 114.05 meters squared per second squared. Taking the square root of 114.05 gives a final speed of approximately 10.68 meters per second. This result makes physical sense. Since the net work is positive, meaning the applied force does more work than friction removes, the crate accelerates from 8 meters per second to approximately 10.7 meters per second. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.